In section 5.5, we're going to be dividing polynomials. So first, we're going to start by doing polynomial long division. This process can be kind of tedious. We are going to learn a shortcut by the end of this video. So first, I want to divide 4x squared plus 23x minus 16 by x plus 5. What is the quotient and remainder? So I'm dividing that equation by x plus 5, so I'm going to write it out that way. And I'm going to do long division in the same way that you would do just any whole number. So I start out here looking at my leading terms, and I want to know x times what would give me 4x squared? That would be 4x, so I drop that down, multiply these guys together, and I get 20x, and then I subtract that. These cancel, I'm left with 3x, I'm going to drop down that minus 16, and I'm going to do the process again. X times what would give me 3x? That'd be positive 3. I drop that down, I multiply my next terms, I get positive 15. I'm going to subtract that, and I'm left with negative 31. So from here, I know that my quotient is 4x plus 3. My remainder is negative 31. And what can be helpful with using division for polynomials is using polynomial long division can help you check factors. So the division algorithm in a fancy way basically explains if I have a polynomial p of x, I divide it by some equation d of x, and I get my quotient expression. My remainder is going to tell me some things here. If my remainder is 0, then that means that p of x, or my polynomial there, is equal to d of x times q of x, or my divisor times my quotient. And that would mean that d of x and q of x are both factors of my polynomial. Okay, so basically that's a fancy way of saying if I do long division for a polynomial and I don't get a remainder, it divides perfectly into it, that would mean that whatever I divided by would be a factor of that equation. So in this next example, I'm trying to figure out, is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? So I'm going to write this out. Also, it's important, notice that I have placeholders in expressions where I don't see a term. So like I don't have an x to the first term there in my divisor, so I added a placeholder. You'll see where this is important later as we go through dividing. So to start, I want to know x squared times what would give me 3x to the 4th. That would be 3x squared. I drop that down. I multiply my next terms. This would also be a 3 technically, even though it's 0. It's not really going to matter, but 0x cubed. And then I have plus 3x squared. Notice how that placeholder kept my x to the 4th power, x to the 3rd power, and x squared. Those all kind of lined up. That's the purpose of the placeholder. I subtract. Those terms cancel out. I'm left with negative 4x cubed plus 9x squared. I'm going to drop down my 0x and do the process again. X squared times what is going to give me negative 4x cubed? That's minus 4x. I bring that down. And then I multiply out the rest, subtract again, and I'm left with these canceling. I have 9x squared, 0 minus negative 4x. Notice minus and negative will turn positive, and I get plus 4x. Drop down my 5 and do this one more time. I would have to do x squared times 9, bring that down, multiply everything else out by 9, subtract. Those leading terms cancel. Also, as you're doing division, those first terms should always be canceling. If you get something that doesn't cancel, I'll kind of go back a step and readjust. And then I'm left with 4x minus 4 there is my remainder. But the key here there is that I just have a remainder at all. So the fact that I have a remainder means that x squared plus 1 is not a factor of that polynomial. So finally, kind of the shortcut here, an easier process of doing this is synthetic division. And synthetic division simplifies the long division process by dividing a linear expression, x minus a. And what makes this a little bit easier is that I'm only writing the coefficients here, including those 0 placeholders, in standard form. So I'm not working with the x's themselves, I'm just looking at the coefficients. And then the other step here, for my divisor, I reverse the sign. So if I'm dividing by a factor of x minus a, I would use the value a as my divisor. So let's use synthetic division to divide x cubed minus 4x squared plus 51x minus 54 by x plus 2. Again, since that factor is x plus 2, I'm going to reverse the sign. And now notice I'm only going to write the coefficients. So I have 1, minus 14, 51, and minus 54. Didn't need any placeholders here, so those are all my factors, or coefficients, not factors. And here's how I'm going to start this process. I would definitely make sure you're paying attention here. How you start this process, you want to make sure you get down right. As long as you set this up correctly, the whole process is pretty easy from there. What I'm going to do is I drop down that first coefficient, I multiply it by my divisor, and my new number goes there. I add those terms together, and then I do the process again, and I just keep repeating till I'm done. So negative 2 times negative 16 will give me 32. I add these together, I get 83. Multiply again, add them together, I get negative 220. So when I divide, my quotient is x squared minus 16x plus 83, and my remainder is negative 220. So the last thing that we'll talk about in this video, I know there's kind of a lot to go over here, is the remainder theorem. So the remainder theorem means that if you divide a polynomial p of x by a factor of x minus a, then any remainder that you have would be p of a. So in this last equation, if I plugged in negative 2 to that x cubed equation, I would get the value negative 220. So let's look at a final example here. I have the equation x to the 5th power minus 2x cubed minus x squared plus 2, and I want to find the value of p of 3. Now again, you might be thinking, literally, why would I do this? I could just plug this into my calculator, which, great way to double check. Synthetic division is going to be a really important process if you take any upper level math classes, especially like calculus, mainly calculus, where just knowing how to do this process will be important. This is one way to be able to find these values, so this is why we're kind of learning this now. So if I'm dividing by if I'm finding p of 3, I'm technically dividing by the factor x minus 3. Really, I'm just using 3 as my divisor, and I write out all my coefficients here. Notice how I have placeholders for an x to the 4th power and an x to the 1st power. And I'm going to go through this process again. So I drop down my 1, multiply 3, add, multiply again, add them together, multiply again, add, multiply again, add those, and then finally I multiply 3 times 60, I get 180, add those together, and I get 182 as my remainder. So p of 3 for that equation is 182.